Okay, and all I've got left for you now is the exam style question. So we'll just have a look at another one, and this is a chance for you to have a go at it by yourself. So, given that f of x is 5x squared, prove from first principles that f dash of x is 10x. First thing is, remember, f dash of x is just, it's the equivalent of dy by dx, yeah? It means f of x differentiated. Okay, so this is basically exactly the same example, okay? The only thing is we've got a slightly different function. We've got 5x squared. Okay, remember that formula. I'll write it down for you. So it's the limit as h approaches 0 of f of x plus h minus f of x over h. That's what we need to try and apply. So for you, I've already told you what f of x is in the question, so you need to figure out what f of x plus h is. Remember, we just replace the x with f of x plus h, stick it all in the formula, simplify it down, try and cancel this h on the bottom, and then when you get right near the end, just set h equals 0, and that should simplify out to give you the answer, which we know should be 10x. The nice thing about these questions is they normally give you the answer, or at least you know what the answer is, because you can just do the multiply by the power, take one off the power rule for differentiating, so you should know what the answer is, so you can tell if you've got it right or wrong. Okay, so pause the video now and have a think about this question. See if you can follow the steps and have a go at differentiating this from first principles and applying this formula, and I'll go through the answer with you in a few seconds. Okay, hopefully you've had a chance to have a look at that question and have a think about how you might answer it. Don't worry if you didn't get all the way with the answer. It's a tricky topic. Have another look at the video to try and understand what's going on if you weren't sure about it, but I'll go through the answer now. Okay, so I'll write out that formula again for what we're going to apply. It's a really important formula that you should get in your head early on. It's quite complicated, I know, but it looks like this. Okay, so f of x, we've already been told in the question, is 5x squared. We also need to work out what f of x plus h is, because we need that in the formula here. Okay, so remember, all I said was replace the x with an x plus h, and there you go, simple as that. So it's x squared, so it has to be x plus h all squared. I'm just going to figure out what this bit is now. So it's 5 lots of, if you remember we did this one before, this x plus h squared, you should get x squared plus 2xh plus h squared. And multiply all that out, just multiply everything by 5. I get 10xh plus 5h squared. Okay, I can start to apply my formula now. I get lim as h approaches 0 of, I'll substitute all this in for my f of x plus h. So I get 5x squared plus 10xh plus 5h squared. And minus f of x, which is 5x squared, all over h. Okay, let's have a look what we can simplify. As I said, this first term and the last term will always simplify, okay? They're going to disappear. So I'll rewrite that. All we're left with is 10xh plus 5h squared over h. You can probably see these examples start to look very similar. This looks very similar to one of the examples we did earlier in the lesson. And that's one of the good things about this topic. If you do enough examples, you should be okay with this topic because there's not that many things they can actually ask you. We can start to cancel the h now. So this h in the bottom cancels with that h and that square disappears. So I'm just cancelling h from the top and from the bottom. That leaves us with lim as h approaches 0 of 10x plus 5h. And remember this term, we said h is approaching 0, so it's going to be about 5 times 0, which is 0. So that leaves us with 10x, and that is our dy by dx. Okay, and that's everything I've got for this example. Hopefully that makes a bit of sense, and that worked example helps you understand what's going on. And that's everything I've got for differentiation. Next time we're going to be moving on to integration, which is the sort of sister topic of differentiation. It's kind of another part of calculus, which is differentiation and integration together as a topic. And it's quite similar, but everything's sort of the opposite way around. So I hope you found that lesson useful. It's a tricky topic. Don't worry if you didn't get it first time around. Have a watch again and try and understand why that formula works and how to actually apply it. If you have a look at the website at Solve4x, we've got loads of quiz questions and practice questions for you to have a go at. I'm afraid there's not many past paper questions on this because it didn't used to be on the old syllabus. This is something new for you to tackle from 2017 onwards. So there won't be any past paper questions, but on the website we have made some questions, made some practice questions for you to have a look at, so you'll get a bit of practice from those. There's also a summary of everything we've been through. Okay, thank you very much for watching this video, and I'll see you again next time.